Hello everybody, this video is going to be about the properties due to intermolecular forces. We're going to see how increasing the amount of intermolecular forces changes the way a substance behaves. How does it change its properties? So a couple of key vocabulary terms before we really get started. Intramolecular forces are the forces that hold the atoms inside a molecule or compound together. So that's what we usually think of as the bonds. They're relatively strong. That's what's holding the atoms connected to each other inside the molecule. So things like ionic or covalent. When they're strong enough, we call them bonds. So you've usually heard it as an ionic bond or a covalent bond. A very similar sounding word is intermolecular forces. This is the new part. This is the attraction or potentially repulsions which act between neighboring molecules. So it's what's going to hold molecules next to each other. They're very weak. Because they're so weak, we don't really call them a bond. We usually call them a force. It implies that it's weaker. In the picture at the bottom, you can see here we have two molecules. The atoms here are connected with a bond, an intramolecular force, which is really strong. But here, the interaction between the two molecules is an intermolecular force, and that's more weak. You're going to notice that we tend to use dotted lines to represent our intermolecular forces. Because they're so much weaker than a normal bond, we want to make sure that we're showing that somehow in our diagrams. We don't want to use a solid line, we want to use that dotted line. And that just helps us emphasize that it's a much weaker attraction that's happening. If there are a lot of intermolecular forces happening, then what ends up occurring is the molecules are going to end up held near each other, kind of like if you put a bunch of magnets together. You're going to end up with kind of the positive end of one lining up with the negative end of another molecule from that polarity that we learn about. The more IMFs you have, the stronger they're being held near each other. It's cumulative, right? It's additive. The more forces you have, the stronger altogether it is. And the harder it is to separate the molecules away from each other. You have to put energy in to pull these away from each other. Just like if you were holding two magnets, you'd have to pull the magnets apart to get them away from each other. If it's a strong magnet, you would have to pull harder. If you had a lot of magnets together, you'd have to pull harder. So the intermolecular forces are a similar idea. Some of the properties that are going to be related to this topic of intermolecular forces are things like the boiling point, meaning what temperature does it boil at? What temperature does it go from a liquid to a gas? Melting point, what temperature does it go from a solid to a liquid? What temperature does it melt at? Something called viscosity. Viscosity is how thick something is. The more thick it is, the more viscous it is. And then the last one that we talk a lot about is surface tension. You probably learned about that in biology, and we'll kind of do a little activity that will go over these as well. So when you increase your intermolecular forces, your IMFs, all of those property values are going to increase too. Your boiling point will go up, your melting point will go up, your viscosity will get higher, your surface tension will get higher. So the more forces you have, the stronger your forces, the higher the properties will be. So kind of like I said before, we'll boil at a higher temp, will melt at a higher temp, it'll be thicker, it'll have more surface tension, And this is all because it's harder to separate the molecules away from each other. They do not want to be pulled away from each other. So you have to put more energy in to make that happen. Another property that we're going to talk about is how things mix together. So one of the things that you probably know from just daily life is that not all substances will mix with all other substances. If you think about oil and water, if you mix those together, they don't mix, right? You pour them in a container and they separate. That's because they don't want to be near each other, because their polarities are different. They have different types of intermolecular forces, and so they are not a good match. So polar substances like to mix with other polar substances, but nonpolar substances like to mix with nonpolar substances. When you have polar and nonpolar things, that's when they don't like to mix with each other. We say they're not miscible. So the property, it's not called mixing. The fancy science word for that is miscibility. Is it miscible or non-miscible? We have a silly little phrase. We say like dissolves like, or like mixes with like. And that's to try to help you remember that polar things mix with polar things, and that non-polar things like to mix with non-polar things. So let's go through a couple of examples. If we have HBr and Br2, we should know now that HBr is polar and Br2 is non-polar. When things are polar, they're going to have more IMFs. So if they have more IMFs, they have higher boiling points, higher melting points, higher viscosity, higher surface tension, all because it has more IMFs. We can also predict whether or not these two things will mix with each other, if they're miscible or not. We have opposite polarities, right? We have polar and nonpolar. So that means they will not mix. They do not want to mix together. Let's try another one. If you have F2 and Br2, they're both nonpolar. So based on our phrase, like mixes with like, we should be able to tell that these two things will mix. One last example. H2O and CO. We should know that those are both polar. Because we have our phrase like mixes with like, we should know that those two things will mix with each other. That's pretty important when you're trying to make chemicals for the labs, right? You have to know if I put something in water, is it going to dissolve or not? Or are these two liquids going to mix together or not? So it's pretty important. Okay. All right. The rest of this lesson is going to be watching two videos. One will be a crash course video about polar and nonpolar molecules, and one will be just another little random YouTube video that I found also about polar and nonpolar substances. The links for those are at the end of the PowerPoint, so you can see them here. So watch those videos, keep taking notes because they are part of the lesson. All right? I hope that was helpful. Bye, everybody.